Thank you so much for everyone coming for this talk. How many Appium users in the room? Wow, that's a lot of number. I didn't see that coming. Okay, cool. Quick intro, my name is Sai. I work as the Director of Engineering for Lambda Test, a very active contributor to Appium for roughly about 7-8 years now. And I'm also an open source evangelist. I've learned a lot from the community in the past roughly 13-14 years. So I think one way to give back to the community is through open source, talk in conferences, share my learnings. Yeah, that's about me. Srini.
Hi, I am Srini, and I am Director of Engineering at Lambda Test as well. And I'm a conference speaker, Appium member and maintainer, and contributed to various open source repositories, including Selenium, WebDriver.io, and a lot more. Yep. And we are here to discuss some of the challenges that we face when dealing with DOM. How many of you have used locator strategy accessibility ID? Wow, nice. How many of you have used XPath? Great. So when we talk about challenges, definitely we can't leave XPath. So let's start with XPath. So that's a major problem statement when it comes to dealing with DOM-based element detection. It keeps changing when the underlying tech stack upgrades, for example, or it is different for certain platform and the strategy is different for different platforms. So that's another constraint, for example. And element sometimes gets exposed properly on Android, but not on iOS. And for a certain tech stacks, for example, like React Native, when dealing with DOM, we have to also include test ID and accessibility ID, depending upon the platform that we are automating. I mean, if developer doesn't do it properly, it's very difficult to automate it or identify an element using appropriate strategy. So people does complains a lot more that Appium is not able to identify this element, doesn't get exposed. It's not due to Appium, it's the underlying tech stack that doesn't expose it properly. And probably we can sit along with developers, encourage them to add test ID and accessibility label, but what if the developer uses a community-based React component, for example, right? It may not have test IDs and accessibility labels. So it brings its own challenges in terms of identifying an element through any of the standard locator strategies, be it Android or iOS. Although we code once on React Native and power it for Android and iOS, it's sometimes we might have to use accessibility ID for Android, and for iOS you have to use NS predicates or XPath or class chain or any other available locator strategies for that specific platform. Again, another challenge. And shifting from React Native to another tech stack like Flutter, same problem. The developer has to have semantic labels configured properly so that it gets exposed and the elements are able to detect. Appium is able to detect it through available locator strategies specific for Flutter, right? So semantic label plays a vital role in case of Flutter. So shifting to native, let's say, assume we use Jetpack Compose from Android. So it has its own constraints in terms of exposing elements on Android, right? So when we shift or upgrade from one version of React Native or Flutter or let's say for Android as well, again, it brings in its own challenge. We are able to see those elements in Android, but not in iOS. And interestingly, on yesterday's workshop, another attendee has came forward with another interesting problem statement that I'm in a payment screen of my React Native app, but when I'm inspecting this payment screen using Appium Inspector, it just shows me home screen related elements, right? Not a problem with Appium Inspector. Again, it's how the hierarchy is exposed in the React Native underlying tech stack. So each of these tech stack has its own challenges and brings everything to testability of application when we are dependent quite heavily on DOM. And we will the users of, the test automation engineers try to change different strategies whenever there is a tech stack changes or upgrades or when the UI changes, for example. So we go back and then identify the certain locator strategy that has been changed, update in test script, and this will be an endless loop. How many of you have faced this situation? Yeah, quite a lot. Awesome. And how we could solve this problem, right? So that's where we are introducing vision-based element detection. So what if I give if I give a service that instead of DOM, let me give it a visual screenshot of my mobile app, and it helps me identify there is a login button on this specific location. So now you can give that instruction to Appium to perform a click on it, or let's say you wanted to perform some action on top of it, right? So it works irrespective of what is the underlying tech stack is. Doesn't matter whether it is Android's own Jetpack Compose, or it is Flutter, or it is React Native, right? So vision-based element detection, giving LLM a screenshot of your mobile app and tuning your prompt to ask what exact information that you need is what we are going to talk about now, right? It works irrespective of underlying tech stack. Let's say we have bringing in a cosmetic change. While scripting, the login button color was in blue color. After two weeks, it became red color because of some valid requirement changes. So element detection works irrespective of the color, so it is resilient to all of these kind of cosmetic changes. But when it comes to DOM-based element detection, let's say it was in blue color, wherein the accessibility identifier around that time was login ID. And then someone changed it to submit. So we go ahead and change it in our test script to make it work, right? Instead of spending time in the business use case, we spend time in identifying it, updating our test script, and this becomes an endless loop. So that's where vision-based element detection comes in place to sort some of these problems, right? So there is no need of any special attributes that has to be provided. So it sees what we see and gives back the results on what it understands from the screenshot based on what we ask for it, right? So that's all about vision-based element detection. And we are going to use certain models. We will go forward and see in solution as a detail what kind of models are we going to use and why we arrived at these specific models. And are they commercial? How is it different from commercial if it is open source? And what challenges it brings in table? Is it a direct replacement? Probably yes, probably not. So we will see everything in detail, starting from an architecture.
Yeah. And before we get into the solutionizing part, or how we can build a plugin based on these, anyone in the room has been exploring or looked through any of these open source LLMs, or probably a closed one in your organizations? A few names you can throw out, people who have raised their hands. What kind of LLMs that you have looked through for test automation? I saw a few hands, so it could OpenAI,
Llama, okay. Claude? Awesome.
Claude, yes. Anthropic, Claude, yeah. Anything else? I heard some name, yeah. Copilot, okay. Anything apart from that? Any open source models?
DeepSeek.
DeepSeek, yes.
Awesome.
DeepSeek. How?
Qwen,
okay.
awesome.
And anything else? Gemma, anything else? The list keeps growing, right? It keeps going. Keeps going, yeah. So even when, I think about 8-9 months back, even when I think Jonathan put out a plugin, and we've been looking through the space of vision-based approach on element detection for the last 8-9 months. So 8-9 months back, when me, Srini, were looking through what kind of models we have, we tried out, because it's all about accuracy, right, for us when it comes. Because you want to click on an element which says save, it has to save, not delete. Right? Delete, it's a disaster for you in your test execution. So when we were exploring 7-8 months back, what kind of accuracy these open source models or paid closed source models can give, like Anthropic or even OpenAI, GPT-4, then a lot of models keep coming. We thought possibly this kind of approach to come up from a vision-based, probably it'll take another 2 years. Like this is what we thought 8 months back. So then we re-looked into it 4 months back, and we thought possibly this is going to take another year, right? So 2 months back, when he jumped in to see what kind of models, again come back, try, see if we can fine tune things. And surprisingly, what we thought will take another a year, from 2 to a year, it turned out, we could do it, right? And that's a kind of change that we are seeing, how these LLM, models are changing, growing, this new thing. Possibly by end of the day, the models, what we said, may not even look good. Maybe you'll have a better model to try these things, right? So with all that experiment for the last, few months, we have come out with some of the best. Closely, roughly about 70% is what we could say. We could see some accuracy in these models. And maybe this 70% can also become 80 or 90 with some other model which can come down the lane. So we're talking about plugins, right? Even in today's State of Union, Jonathan was talking about plugins, how powerful a plugin can be. And even in the workshops we built a plugin yesterday. We understood a lot more about the plugins, right? I know everyone was not there in the workshop, so probably we're going to also touch base a bit about what is a plugin and how a plugin works so that we could understand a bit more into it. So we're going to name this plugin called as Find by AI. What is Find by AI, right? A lot of Appium users, a lot of Selenium users in the room. So typically what we do is any command we write, we basically say driver.find by accessibility ID, XPath, class chain, whatnot, whatever the platform supports for us, right? So similar way, through a plugin, we want to introduce a new locator strategy. The new locator strategy is Find by AI. Okay, it could be anything, but we're just naming it Find by AI. And so that's a plugin. So that specific command sits inside your plugin. So you could typically call driver.find by AI. And what we want to do over here is we want to give it a natural language instruction. So an example over here we have taken is click on a login button. And what we're going to do this is we're going to break this one single instruction into a format, into a specific schema. So we're going to break this into possibly two things. One is it's an action. So what's an action here? It's a click. So an action can be a click, type, scroll, swipe, whatnot, right? And a login button is going to be your element. So we don't have a strategy here because it's not an XPath, it's not an ID. So we don't have a strategy here. So it's basically just a locator for us. So we're going to give it to one of these LLMs. So we're going to talk about all open source LLMs today and how you can run these LLMs. Can you run it in your local and things like that? So we have taken DeepSeek here. And DeepSeek might be a little, possibly a larger model as a reasoning. We can also use QN2. So that's pretty small. It's just about 1 gig. You can also run it in your Macs. So we could use either one of them. So we destruct this instruction. And we also wanted this plugin to wait for the element to be visible, right? So generally what happens in our traditional approach of test automation, you use a lot of explicit waits, right? You say expected conditions, wait for this element to be clickable, visible, invisible, whatnot, right? So we also want to embed this element visibility because before you go and perform any action, you want to make sure the element is in the screen, right? Which is the login button in our case. So we want to, again, take a screen grab, give it to one of the models, and make sure that the login button is actually visible in the screen. And again, you can play around with the prompts here to make sure that login button is not overlapped with another element, it's fully visible, and things like that. So it's again, one part of this plugin is also a prompt game for you. Sometimes you might also see false positive. Why? Possibly you can make the prompt better, tell it even more in detail. Because what I've seen is I have a 5-year-old, I tell him don't do something, he keeps doing that, and I've seen these models also behave the same way. When I say don't do, it still does the same. So we keep improving the prompt, make it better, and things. So once the element visibility is done, we get the bounding boxes, and for this we've used OmniParser version 2.0. I think most of you might be seeing browser use, computer use, browser use, and things, right? Similar to that, we'll come over there. And once we get the bounding boxes, we actually give it to Appium. So basically, Appium can execute these commands based on your locators, which we know, we have already talking about it, your XPaths, IDs, accessibility IDs. Appium can also execute any actions based on coordinates, right? So you give it any coordinate, it will execute, right? You give it a wrong coordinate thinking that, the coordinates, let's say 100 cross 200 is for the login button, it will just perform that action. So Appium doesn't know that 100 cross 200 in the X and Y coordinates, it's the login button. So calculating these coordinates is very important for us in a right way, okay? Can I just take what OmniParser gives and just give it to Appium? No. Okay, and we'll see why, right? And this is where I was talking about how the instruction can be broken down. So action is going to be your click, your value, and your locator. Why value? Sometimes you might also want to enter certain text, right? So you need a value, and your locator would possibly be a username field, and your value could be your username. Could be an admin or your email ID and things like that. And then wait for the login button to be visible. For this, we will actually give it an image. We give it a prompt and be more specific with the prompt to say, is the login button visible in the given image? And I basically want to return a Boolean, right? It's just a true and false. If you don't explicitly say this, some of these models are over smart. They give you an entire history, probably for 200 lines with all the explanations. So we don't need all of that. So I want to cut it pretty short. Just say it's available or not there for me in the screen. And if you see, this is how your output for the OmniParser would look like. And if you see on the left with the image, it draws these bounding boxes for you nicely. And on the right side, if you see, it gives you all the coordinates for each of these elements that it has spotted for you. Okay, and it also labels them with the content. It says home. It probably can say a search. It can possibly say there's a notification icon and things like that, right? So this is the output we would get from OmniParser now, okay? What do we do with this output, right? It simply says 0.952755, and there are some random numbers out of it. So I'm sure that if you take these coordinates, give it to Appium, it will quietly just go perform some click somewhere, and when you see, you would expect a login button to be performing that action to click, but nothing is going to happen. Why? Because another challenge over here for us is, when you send this screen grab to any of these models, possibly the model descales that image, does its work, and gives you the output, right? But I've taken this image, let's say in a Galaxy 22. You might have multiple devices with different resolutions as well, right? Maybe a Fold, maybe an iPhone, but what happens now, your coordinates would basically change, right? So you need to recalculate these bounding boxes based on the device's resolution. So we need to do a little bit of math over there to take this, recalculate the coordinates, and then try to perform the action through Appium.
Yeah. Another challenge, if you look at the previous image, it does club certain icons together on the right top corner. So if you want to identify something precisely for, let's say, tower or Wi-Fi icon there, it's going to be a bit difficult because it does club certain things and shares the coordinates or the bounding boxes, which is the left top and right bottom corners. So if we do a center, then instead of clicking in battery, it does probably ends up clicking in network or somewhere else, right? So there's some challenges, as that's what Sai was talking about, 70% probably, right? So now that we know our plugin, and plugin is going to hold 3 different models for serving different purposes. It's also important to understand, we have been talking about plugin since morning, right from our keynote. So it is also important to understand how does Appium works end-to-end as an architecture. Just a recap before we get to see everything in action, right? Let's say we have driver.findElement written in any of the client languages that Appium supports, be it Java, JavaScript, Python, Ruby, and even Swift, for example, right? So the command goes to the Appium server. Appium server is smart enough to understand whether it needs to talk to specific driver. For example, Appium does supports UI Automated 2 driver for Android, Espresso for Android, XUI for iOS, even macOS driver, quite a lot of drivers, right? Depending upon the capabilities, the driver gets created, the session gets initialized, and based on that, it takes an action, whether it has to talk to Espresso driver. Let's assume here we have Espresso driver. So it has to talk to the Espresso driver. What Espresso driver down the line does is it installs Espresso server inside the mobile, where the application under test is also available, right? So it sends the command to application, the Espresso server running inside, does port forwarding to send the command to Espresso server running inside the device, which eventually takes the sole responsibility of communicating any information with the application under test running inside your mobile device. So it sends back the response, 200, 500, whatever, it sends back the response, and the server sends it back to the client, and client says, depending upon the status code, it says whether it is no such element exception or 200, everything is good, well and good, or it's 404, whatever, right? So now it's the typical life cycle of any driver.find element. So Appium plugin comes in place without disturbing any of these core ecosystem, core modules of Appium. It helps you to introduce any new command. That the new command that we are going to introduce for Vision plugin is Find by AI. So it helps us to introduce any new command without disturbing the existing core modules or any of the drivers available in Appium. So while starting the Appium server, you need to instruct Appium server, hey, I have an Appium plugin called Vision. It's sitting in my device on this place. Can you activate it? And if server gets a command called, let's say, Find by AI, server is smart enough to route that command to plugin, because the plugin gets activated as soon as we start the Appium server. Right? It routes that command to plugin. Plugin takes the sole responsibility of transferring that command, the basic instruction, to the Espresso server running inside the device, which eventually does based on what we have asked for, which is driver.find element through Vision. So it does makes probably all of those things that Sai was talking about, talking to DeepSeek, talking to QN, talking to Omniparser, and sends appropriate instruction to Espresso server. So Espresso server can talk to or perform the Appium action inside the application under test in the mobile device. So it sends back the command, and now plugin can do two things. It sends the command back to the driver, or it takes the responsibility of sending the W3C contract back to Appium server in a structured format so that clients can understand whether it is 200, 500, or whatever, right? So plugin in a nutshell can help you to introduce new command, can also override any existing commands. Let's say, I think we overridden find element yesterday in our workshop yesterday, wherein whenever there is a find element, probably we also added a log saying this is the strategy, this is the value, which we are going to use it. Once the plugin does the printing of the log, then it sends a command back to appropriate driver to do the actual stuff, right? So it can override the command, it can introduce a new command. So this is a quick recap about where does plugin fits in. Now let's go ahead and see everything in action on how does this goes forward and execute everything, right? Let's see a quick demo. So here we have a short script, and we have a React Native based application running on your right side called Hodka. So the instruction that we are talking about here, you could see, clear the admin text in the username input field. Yeah, it does it. It does the clear for password. It enters admin in the username field. And we have enabled the show tabs and show cursors in the emulator that is running on right side so that we could have better visibility. And it performs a click on drag and drop. It lands in drag and drop screen. Performs a click on the back button. So behind the scenes, it makes a call to all these LLM models that we have talked about. And it uses Actions API to perform the scroll up instruction.
And all these instructions that you saw, typing, clicking, scrolling, is all purely the instructions driven by Appium. So before that, like Srini was saying, we do pass through all these stages of these LLMs, and then end of it, the actions are purely performed by Appium, actually. So that's where we are trying to plug this plugin with Appium, so it has to live with Appium over here. And you could ask why so many models around, you're moving here, you're moving there, doing this and stuff. I'll be happy to hear from you if there's one model which can do all of this. One model does something very better in reasoning, like Claude. Claude does amazing reasoning or even to validate whether things are there. It's really, really amazing. But when I ask it for a coordinate, if I ask the coordinates for that screen, however the prompt has been tweaked 10 times, from the first time to the 10th time, is giving me 10 different answers, 10 different coordinates. Even if Claude can give me even the seven times the same coordinates, I would be happy. At least I could trust that model for something. But 1 to 10, it's different coordinates. So to figure this out, what me and Srini did is whenever we get these coordinates, when we recalculate it, we start plotting them onto the screen, right? Because these are all coordinates, right? So you could take these coordinates, probably draw a dot around the screenshots to see where. And when we look through some of the sampling aspects with these models, especially for the coordinate things, I think we ended up with image like what Diego was showing today, people across the globe, so many points coming in. So for the same screen, we had multiple points saying, okay, click on the login button. So it used to say randomly the login button is on the right, is on the left, it's on the bottom, and things, right? And also when we go with these kind of models, I think one more thing that should really, really help us when we go with these LLMs is proximities. I mean, because you might have two logins, right? I think even in this example, if I slightly go back 1 minute, okay. So you have a login here, and you have a login here also, right? So we need to also make sure when we build these plugins, and you could simply say, I want to click on a login button, which is near to the password field, right? So I want to click on a login button, which is to the left, to the right, right? So you get more flexibility when you work with these kind of plugins. So if anyone knows any model which can do good reasoning and also look through the image and also give us the coordinate, I think I'm waiting for that day. I think we don't have to do, multiple, models, and some can be hosted locally, some cannot, because very large. Because some models, even with a 7 billion parameters, it doesn't work out. So we have to shift to a 72 billion. But what's the cost behind that? How would you host such a big model? So you need a really beefy machine. You need a good GPU. So there are pros and cons to these kind of approaches as well. So as we have seen the demo, now I'm going to quickly run through the code. The code is open sourced. So you could also go back, take this code, run it in your machine. But I'll quickly run through how the plugin is, what we have written, and things like that. So I'm not going in detail about how to start the plugin, run the plugin, build the plugin, but I'm just going to run through the code and what we have done. So if you see through here, okay, and that's the find by AI. So whenever okay, I think it's good I start from the script which triggered it, right? That's our test. So give me a second. Okay. So we have a simple WebDriver test over here, which basically does this. So this is the exact text that you saw, which ran in the machine. I hope it's visible. Yes. So I'm simply saying AI, enter the username as an admin, blah, blah, blah. And also, if you see what this AI command basically holds is this, right? This is the interesting part that we want to see. Driver.execute, vision by, find by AI. Right? And this is exactly the command which is there inside the plugin now. So I'm going to move into plugin. So whenever the driver.execute is being called with vision : find by AI, and that's when we get into the plugin, which is this. So it comes into this block, okay? And from this block, what we do next? So we have done exactly what we've already, discussed, which is we go in, we basically take the instruction. So there's a prompt out here, so you can look through this. We have just given a simple example to the prompt to say how you want to break down the instruction that the user has given to you, okay? And we are making an API call here. Okay, so we're going with DeepSeek, a 32B, and we get a response, whatnot, we take the passed instruction. So the output of this instruction would be similar to this: action, value, and your locators. So once we get the passed instruction, what are we going to do next? So we have the instruction, so we know it's a click action. So now the next thing is we want to do is we have to wait for that element. We want to wait for the login button like we discussed before we perform the action. So for that, what we do, this is the best part, right? So you want to get the window rect. So you could simply say driver, because the plugin is actually embedded into the server. So which means the plugin has much control with whatever resides inside the Appium server. So I get the rect, and we wait for the element. And when we wait for the element, this is where we're going to grok, because grok has got good interface. We can't run all of the things in our machine. So we go to grok, give it a screen grab, and again, a prompt to say, is the instruction, which is nothing but the login button, visible in the image, just return me, blah, blah, blah. And if you see, we've also explicitly said that do not return any explanation or any other text, otherwise it just starts giving a lot of information. And I also said I will be very unhappy if it returns anything else, right? So, yeah. But it still makes me unhappy, okay then. Every time. Once we wait for this element, again, wait for the element is possibly something that you can put it into a polling. So you can try it X number of times. And then we find the best matching element, which is nothing but, I think I missed out one step, about finding the bounding box. So I go to Hugging Face again, because OmniParser is hosted there. So we go to Hugging Face, I just give it a screen grab, and based on the screen grab, it's going to draw all the bounding boxes for me with the coordinates. So I get all of that, so it doesn't stop there again. So what we do next is, we want to find the best matching element, right? Because imagine there are like about 100 odd elements in your mobile screen. So it's going to be a massive bounding boxes out there. So we're going to give that entire bounding box with the instruction, which is nothing but your login button. So we're going to pick the best bounding box out of it. And this is where I was talking about the calculation part, because now we want to upscale the image back to your device resolution. So we have a simple math here based on your screen width and height. So that's this part. So based on the screen width and height, there are a bunch of things that we do. Okay. And at the end of it, we basically get the X and Y in pixels, center, and in multiple ways, right? Okay, so we have the bounding box now. This is the place where we want to pass this instruction out to Appium, saying that, hey, if the passed action is a click, you can perform a click. And if you see over here, we're typically not using driver.click here, because we want to follow the W3C actions, because you have more flexibility when you do anything with W3C actions. You can build a keyboard type in, or you can do a click. So you can build a reusable code here. So if it is a clear, if it's a click, so for every action, we have built a W3C actions over here, right? And including the scroll part. So once this is performed, and that's when your click typically happens in your real device. Okay. This code is out there. You can go refer to it, look through it, and things.
Yeah. Now that we have built vision-based element detection, are we good to replace all the DOMs with the vision? Probably yes at some places, no at some places, depending upon the use cases. Right? Let's do a quick draw or comparison about how it differs from vision and DOM-based element detection. Setup time, again, you don't have to go forward and check whether the login button accessibility identifier is login ID or it is submit. It's quite faster in terms of that, right? And resilient to all these UI changes, right? And next is maintenance. You have to keep feeding in images and tuning the instructions depending upon what it looks like. And it's cross-platform. You don't have to find NS predicate for one platform and for another platform, right? But it does comes with its own cost, right? Is it accurate? We have seen in OmniParser that the bounding box has grouped quite a few elements, right? It doesn't identify certain icons, for example, right? It just groups all of these into one, right? So those are cases. There are certain places, for example, underlying tech stack doesn't expose the elements properly for Appium to detect it through any of the locator strategies. Probably that's a good place for us to introduce vision-based element detection, right? So having a mix of both and figuring out where it works best for you is making a lot more sense rather than replacing everything. but it's a good starting point in terms of overcoming some of the challenges that we have in DOM-based element detection with the vision-based element detection. As day goes past by, we have tried a lot of models, right from YOLO and DeepSeek V3, quite a lot of models we have tried when it comes to element detection, and it is still evolving a lot. So over a period of time, I am sure we'll have one model probably does all element detection, coordinates, and it should be able to identify any different icons, whatever that we ask for. It does, hopefully, in future.
Yeah.
Cool. Thanks. Thanks a lot.
And just to add for another point is, I think one of the best places that we have seen these kind of vision-based approaches can work is your assertions, right? So it gives you a lot, because it also explains you what's out there. So when your assertion fails, these days when we do a traditional assertion, we say, hey, Srini as a username is not visible. I know Srini as a username is not visible, but what is visible to me? So if these kind of approaches can tell us what's visible, so your debugging in your CIs gets very easier. Okay, if Srini is not there, so who else is there, right? So it gets easier in your assert statements as well. And I think we are still seeing accuracy is, let's say if you're taking an application which has got ticket booking, and if I want to click on a seat with F6, and I think that's the kind of coordinate points we're looking to click on F6, not at E6 or not somewhere right and left. Today's state, the accuracy to that level is not there with all the models that we have seen, right? With that, we want to say thank you. Thank you so much for listening to us. Thank you. Open for questions.
Howdy. I want to preface this with, I'm impressed by this. It was really cool to see two very competent engineers give this the best possible chance of, like, you know, succeeding. And I think what I saw today was really cool. That being said, like, if I was trying to impress a bunch of VCs, I think this would blow their mind and get me a lot of their money. But as someone who has to write tests that are reliable, having models that are 70, 80% accurate, if you just look at the laws of independent probability, like, if you use this 3 times in a test, you're less than 50%, right? So I guess my question is, like, I guess one, this is really more like execute with AI rather than find by AI, which is really cool, because it doesn't just find it, it also does something.
Yeah.
It doesn't. But am I right in saying that, like, if I want my test to pass with any reliability, I guess there was a slide there that showed sort of the difference in maintenance costs. And I feel like in terms of, yes, it's more flexible to UI and DOM changes, but every time I upgrade my AI model, et cetera, every time my app changes, stuff's going to break. I guess my question here, Bill Gates said that 25 years ago, we'd lick spam in 10 years, and I still get 1 billion spams a day. So I'm wondering, do you guys have faith that these AI models are going to get to a point where I have 99, 100% accuracy finding stuff? I just don't see how this is usable right now, if given test reliability. I'll leave my question there.
I'm hoping to see that day, Dan, but right now I'm still seeing it only 60 to 70% work. But I mean, if 99% is something that comes, it'll be good. But as of today, I don't see that happening.
Yep.
And that's where I said in the beginning, all these models we've been exploring just not for a month or two. It's like about 8-9 months. We've been trying different models. We are seeing it. It was 40%, so now it's 60-70% odd. So there's a 30% in the last 1 year. So yeah.
I think this is what conferences should be about. I love seeing stuff that's very cutting edge and very thorough and well done. And I just want to compliment you on a really rigorous sort of job here. But I'm glad you drew the same conclusion I did, that it's cheaper just to hire someone to do this right now or to teach someone to write code than it is to do this. And it is unlikely to change anytime soon.
It is, but I'm also seeing on the other side of this is, you know, how quick this can help us to write these tests, right, in natural language. You don't have to inspect elements. Inspecting elements becomes a little harder job for us. So when things change, your elements change, right? At least to speed up our test startup or writing time could be useful. At the end, until and unless you know, we get that accuracy from these models, and I think that's where we look for the day where the accuracy comes in play.
71 billion parameters, and you know that they're all trained on the works of Shakespeare, which is probably very useful for your testing. We actually don't have time for questions. Please find them in the hallway track. I think this is great. I think we could be here for another hour and a half with Q&A. So just let's go have lunch, talk about it.
Thank you.
It's be great.
Thank you.
Thank you so much, folks.